I recently got this comment which basically says, I don't think you can trust AI models. They're a bit flaky. And if I was running this on a large data set, I wouldn't be able to fully trust it. And look, I don't necessarily disagree, but I think the important thing to remember is models, prompts, parameters, ground truth testing, they are all different parts of the puzzle where if one is modified could give a different output. And I think it's really important that we do get into the habit of testing, but how might you do that? And I'm going to show you very quickly how we can set up a little bit of testing to go through and test local large language models. Now, I love using Llama. I think it's a fantastic tool to be able to connect to local large language models running locally on your machine. So make sure you got that installed. I'm going to be testing a bunch of different models. In particular, I'm going to be looking at any model that supports tooling, which will include Llama 3.2, Llama 3.1, and the Granite3.2 by IBM as well. I've got some boilerplate code already set up. I'll quickly go through it. So I'm actually aiming to get a structured output about real estate listings. Okay, so that's where that comment came from. And the structured output that I'm looking to get is this JSON schema here. So model JSON schema. And that model JSON schema basically talks a bit about, does this house have does this real estate listing mention that there's a fireplace? Okay. Does it mention that it's furnished? And it has three options: is furnished, is not furnished, or can be furnished or unfurnished. So it mentions an option to be furnished. Then we've got number of bedrooms, which is pretty straightforward, just a count or number of bedrooms, integer. Has it got a carport? Has it got a garage? Now these two are tricky, right? Because these are two terms that are sometimes interchangeably used to describe somewhere you can put your car.
Hey fellas, the garage. Well, ooh la dee da, Mr. Frenchman.
Well, what do you call it?
A car hole.
So I'm not holding my breath on any model getting this particularly right, but we're going to go ahead and test it. So next thing we do is we go ahead and we have a bunch of listings. I've actually got a spreadsheet of all these listings, and I've got some known answers, what I would call ground truth. And what I'd want to do is test a bunch of models and a bunch of variations on prompting to see how well they perform. I was testing this earlier, and what I do is I say models, and I give it a list of models. These are all available on llama.com to make it really, really easy. And here we've got outputs get loaded into an empty list. Then I've got 4 model in models, so we're just passing each model, okay? And in here I've actually got a I've re-engineered the prompt. The original prompt just said extract key values. This particular prompt actually goes into quite a bit of detail. I didn't write this. I got another AI to write this, and I think that's the future of prompt engineering. We're going to be having AIs write their own prompts. In fact, I think the perfect world is where we do some ground truth testing. And what I mean by that is we have some inputs, we have some known outputs, and we compare that to how well our current model is performing. And if it's not working as expected, that gets passed to maybe a state-of-the-art model it's not a human, that can then re-engineer that prompt and kind of retry and kind of go back and forth until it gets the perfect prompt for the use case that we're looking at. Next up, we're passing in home features. We're setting the temperature to 0. So we want to always pick. We want to be greedy in our selection of the top token. We always want to pick the most probable token. We don't want any variation. And then we're just basically adding that into a list. We add the model first. And this is what the output looks like. And as I scroll down, you can sort of see here, we now have this really cool little data frames. We have model, whether or not it has a fireplace. Now this particular listing, it does actually mention a fireplace. It talks about a wood burner. Wood burner fireplace. That's really awesome. And so our expectation is that it'll be true. Now, fortunately, Llama 3.2 1B failed that one. This listing, let's have a look here. So this listing talks a bit about unfurnished, so explicitly says unfurnished. And if I scroll down, does not mention being furnished. Correct. Again, Llama failed us, incorrect. Granite IBM, yeah, doing great. Scrolling over to the right, we've got number of bedrooms. Okay, that is set to 3. That is absolutely correct. Don't know if I can scroll to the right. Has carport, that's false, and has garage is false. So overall, out of all of these models, the 1 billion parameter model for Llama 3.2 has got it quite incorrect. Every other model is getting it correct. And that's really awesome because one of the variables I might change could be something like taking out all this extra prompt engineering that a state-of-the-art model did for me, rerunning that, and let's see how well these models perform now. I might fast forward this part. Okay, we are back. And so without all of that extra prompt engineering from a state-of-the-art model, the results are not as good. In fact, some of them are really bad. Okay, let's start with Llama 3.1 8B. I was expecting this one to stay kind of the same. Fireplace is true, correct. Mentions being furnished. Is that true? Unfurnished. No, it doesn't mention being furnished. Yes, okay. Bedrooms are correct and carport, garage are correct. In fact, all of them got that correct. The model that got it the least correct is Llama 3.2 1B. 5 bedrooms and option to be furnished. Simply not true. Again, the models that performed the absolute best, Granite, IBM's 3.2 8 billion parameter model, got the fireplace true, does not mention being furnished, got the 3 bedrooms, got the carport and the garage. And so going back to that initial comment that talked about large language models being flaky, I think if you were to just blindly run them with a prompt and kind of let it go off and run across 10,000 data points, I too would be a bit nervous around how well it would perform. But if you're willing to test across models, you're willing to test across prompts, you're willing to test across restructuring your input data. So right now we are taking these raw listings. Now potentially we might do an initial summarization or extract the key values, which could potentially not try to interpret the data, but remove out all of the extra filler words. So there's a much smaller context window size that might help the model better interpret whether or not it is furnished. Because right now, mentions being furnished, like Llama 3.1 8 billion parameter is getting that wrong. Whereas Granite doesn't have a problem. Neither does Granite 3.2. Did fail in the fireplace, unfortunately. But, sorry, I just remembered. I take that back. It failed on the fireplace when I gave it very little assistance. Okay, when I add this back in, it performed fantastically. So, yes, lots of testing, lots of prompt variation, system prompting. Maybe you need to reinterpret your data. But I genuinely believe we are entering a world where there will be so much opportunity to extract structured data out of unstructured text, which can then be used in a whole new world of analysis, machine learning, and really cool stuff. Anyway, thanks so much. Bye.